Hello class, this is a video tutorial on differentiating exponential functions. At the most basic form, the derivative of the exponential function is itself. So if you have f of x equals e to the x, its derivative f prime of x is itself. By applying the chain rule, we can differentiate other powers of e. So instead of e to the x, we might have e to the power of g of x. Now notice that this is the chain rule. The outermost function is e to the x. So the derivative of the outer function is itself. But then because of the chain rule, we multiply by the derivative of the inside function g prime of x. I set my work out a little bit more simply. I identify the power of e as u, and I simply multiply the derivative of u to the derivative of e. And of course, all the other differentiation rules, such as the product rule and quotient rule, may also be applied. So let's get straight to some examples here. You can pause at any time and give this a go yourself. So here we go. For this first one, this we can do pretty simply. Its derivative f prime of x. Well, the derivative of this by itself, well, it's just e to the x. That's just using the most basic version of this problem. And now let's do a minor problem of e to the x. Using the chain rule, the derivative of e to the x is itself. Now I need to multiply this by the derivative of the inside function. Well, the derivative of negative x is times negative 1. Let's put that plus there. And so we multiply this by negative 1. So it becomes e to the x minus e to the minus x. So the derivative of this is as shown. Okay, so let's do this again. Now, here's the first demonstration of where you can use the notation of e to the power of u. So as we can see here, u is 4x minus 3. The derivative of this, u prime, is just going to be 4. Okay, so now the derivative of y prime, is itself, so 5e to the power of, x minus 3. But then I need to multiply all of this by the derivative of the inside function of 4. So overall, this becomes 20e to the power of 4x minus 3. Okay, so let's keep moving forward here. For these ones, you can rewrite these using index laws. So first, I'll do this above so we can see. This becomes e to the power of x to the power of half. And this second one, since it's in the denominator, it's the exact same thing. So it'll become 1 times e. So e to the power of x to the power of negative half. Now, from this, we can use some further index laws. This is a power of a power. So this becomes e to the power of x on 2. Or you can write this as to the power of half x, whichever you prefer. Plus e to the power of negative half x. Okay, so from here you can utilize this notation if you'd like, but for this, I'm simply going to go y prime equals the derivative of this is itself e to the power of half x. But then I need to multiply this derivative times the derivative of the power. The derivative of the power is just going to be half. So let's keep moving forward. It'll be plus. The derivative of e is exactly itself, so e to the power of negative half x. And then we need to multiply all of this by the chain rule times the derivative of the inside function. The derivative of negative half x is negative half, so times negative half, which I will simply place immediately here as a half, and I will make that into a negative. Simplifying this into one denominator, y prime. Since these are both denominators of 2, I can write this as all over 2. This first one's going to be e to the power of half x. And the second one will be minus e to the power of negative half x. I'm just going to leave it like this. There are different ways that we can simplify this, but that is, this is simply the chain rule. Okay, so hope to see you in the next video where we tackle the next 3 sets of examples. Hope to see you then, and best of luck.